go over the equipment in the bin first. This is called the test tube rack, and this one can hold up to 6 test tubes. And here's a test tube that is used for holding substances like water, and you can put the test tube on the test tube rack like this. And also, say you have washed this test tube after a lab and you want to air dry it, you can invert the test tube and hold it like this in the test tube holder. Next, this is a test tube brush. It is used for washing test tubes and other glassware with soap water when you're done at the lab. Sometimes a lab calls for heating substances in a test tube, and you don't want to burn your hand. So then you would use the test tube clamp. You hold the test tube like this, and let's say that, for example, you have a hot water bath in this hot pot, and you have the test tube with the test tube clamp, and you want to heat the substance in the test tube, then you can just hold it or set it so that it'll sit. There we go. Beaker. And notice that it has a beak. That's why it's called a beaker. And this is the common size that you will most likely be using in many labs, 250 milliliters. And there's another equipment that also has a beak. Can you see it? But this is not called a beaker. It is called a graduated cylinder. Graduated cylinder comes in different sizes, like this tiny one that measures up to 10 milliliter, or a large one like this that measures up to 100 milliliter. Moving along, here we have a pipette. You used this before in the Blackworm lab. Pipettes are used for measuring liquids usually, and if you stare at it really carefully when you are holding a pipette, our pipettes actually have measurements written on them, and this one measures up to 3 milliliters. Moving along, we have a teaspoon and a lab scoop. They're both used for measuring small amounts of substances. Here are forceps that you have used for dissection. They are used for pinching, holding small substances. Next, you have a ruler. Our ruler has 2 sides. One side is the SI units, or the International System units, and the other side is the English units in inches. This is the one that you're most likely familiar with in terms of measurement, but in science we want to use the SI units, and in this case for measuring the length of something you will use the units millimeter or centimeter. We have 2 kinds of thermometers. This glass one is called the lab thermometer, and the lab thermometer unit is in degrees Celsius. Celsius is a metric unit which came before SI, or International System unit, and sometimes the name is used synonymously, metric and SI, but they're not really exactly the same. Metric system came before the SI system, and in science we still use this metric unit of degrees Celsius often when measuring temperature. And the SI unit of temperature is called Kelvin. And we have the digital thermometer. When using it, do not forget to take the cap off and turn the switch on. And most of them have an option of 2 units, either degrees Fahrenheit or Celsius, and once again we're going to use the unit Celsius. When measuring liquids, you have a number of options. In a small graduated cylinder, I have measured 10 milliliters of water, just colored water so you can see better. And in the bigger 100 milliliter graduated cylinder, I have approximately right now 5 milliliter. But let's say that I want 10 milliliters in the big graduated cylinder too. Well, you have a number of options. What you can do is to have your liquid in a beaker like this, and you can use the pipette to squeeze out the liquid and continue squeezing the liquid with the pipette into the graduated cylinder. And when you think you're almost at 10 milliliter, you can go drop by drop. So that to the best of your ability, you get the correct volume of the liquid that you want. Now, I want to point out one more thing about reading on the graduated cylinder. When you're reading the volume of liquids on the graduated cylinder, you need to look at the eye level, okay? And at the very top surface is called a meniscus. This is not meniscus in the knee, but meniscus is a curved upper surface of a liquid. And when you're reading the volume, you read the lowest tip of the meniscus, which I marked with an X on the figure. Okay, let's continue our lesson on measuring liquids. You had just seen using the graduated cylinder and using pipette to put in the last few drops of your liquid to get the volume that you want. And let's say, for example, you want less volume than what you want in the graduated cylinder. And then there's a handy dandy pipette, you can squeeze it out. And just continue until you get the volume that you want. All right. Now looking at the meniscus of this graduated cylinder, which I know is hard for you to see the measurements, I have about 8 milliliter in it, okay? And let's say that I want to get 10 milliliters back in, 10 milliliters total. Well, then I can also use my pipette, because remember, earlier, our pipette comes with measurements in increments of 0.5 milliliter. So I could measure, say, 1 milliliter with the pipette and then put it in the small graduated cylinder. Okay, that's another milliliter. And here we go. We are back at 10 milliliter. So very useful. Now let's talk about accuracy. Yes, graduated cylinders are used for measuring liquids as well as beakers. They both hold substances which are usually liquids, okay? And notice that the beaker also has scales. All right, let's see what happens if we put in, say, 10 milliliters of water in it. Okay, well, this beaker has increments of 25 milliliter. So it looks like it is approximately half of 25 milliliter, but there's a lot of estimation there. So to be more accurate when measuring liquids, beakers are probably not the best choice, but you want to use the graduated cylinders instead. Next, let's talk about using a hot pot. Some of you may have used it before or seen it before, okay? This is a very handy equipment to have. If, for example, you're living in a college dorm room, you can make ramen noodles in it, or you can boil water to make coffee, and you plug this in. And for our purpose, for most labs, you will heat water in these hot pots, and notice that you have a dial of controlling the temperature from low to high. Next, let's talk about measuring mass of a substance. Mass, by definition, means the amount of matter in a substance. What that means is how much stuff is in an object. And to use a digital or electronic balance or scale, you need to turn it on first and make sure that the balance is sitting on a level surface like your lab table, and check your units. So right now it says small g, which means gram, and that is the unit that we want to use. It's an SI unit for mass. However, on our scales, you can change units to ounce, and go back to grams like this, okay? And before you put any substance on the digital scale, make sure you hit this button that is labeled 0. Sometimes it's labeled tare, as in T-A-R-E. And by pushing the 0 or the tare button, you are calibrating the digital scale, or make sure you're setting it to 0 gram. And then you can put your object. When you're done measuring, hold down the same power button and it'll turn off. Another option to find the mass of a substance is using a triple beam balance. And you've probably seen a bigger version of this at doctors' offices. And it's called triple beam because there are 1, 2, 3. Okay? And before you try to find the mass of a substance, make sure that on all 3 beams, the riders are set to 0, all the way to the left. And if you look at it eye level, make sure that that line is lining up at 0 gram. Okay, so to calibrate a triple beam balance, you go to this adjustment knob right here under the pan and turn it left and right until you get it to about 0 gram. It's at 0 gram. Okay, well, let's find the mass of my same pen. Okay, you always start by using the largest rider, this one right here, that is on the beam that goes in 100 gram increments, as opposed to the one in the back that goes in 10 gram increments, whereas the one in the front has 0.1 gram increment. Okay, so move 1 notch to the right and notice that that line by the 0 mark right here, it's all the way down to 0, which means that my pen is not 100 gram. So I want to put the rider back and instead use the smaller beam, the 10 gram increment. So you move 1 notch at a time. Oh, that same line is still below 0 grams. So this pen, well, as we know from the digital scale, does not weigh 10 grams. So you want to use the smaller rider that goes in 0.1 gram increments. And you keep on moving it until the line is at 0 gram. Getting closer. And the scale's reading 7.5 grams. Okay, so the line's not quite lined up. It's almost there. Let's move it just a tiny bit. And bingo. I read 7.6 gram, which is the same mass that we measured for the same pen with the digital scale.